Hi, I'm Shania. The topic I'm going to discuss today is wireless session protocol. The contents which I'm dealing with are introduction to WSP, that is wireless session protocol, and WSP bar B. WSP bar B over wireless transport protocol. WSP bar B as connectionless session services. First of all, let's look at what is WSP. WSP stands for Session Protocol, Wireless Session Protocol. As we all know that wireless session protocol is a sandwich layer that links WAE, that is the wireless application environment, to two session services. One is connection oriented and the other is connectionless. As we can see in this figure, WSP comes under the session layer, which supports two services, connection oriented and connectionless. It comes between the application layer and transaction layer. The wireless session protocol WSP has been designed to operate on top of the datagram service WDP, that is wireless datagram protocol, or the transaction service WTP, wireless transaction protocol. WSP provides a shared state between a client and a server to optimize the content transfer. That is, WSP provides a consistent interface between two session services, client and server. It provides the cooperating client and client-server application to establish a reliable session from client to server and close in an orderly manner, and agree on a common level of protocol functionality using capability negotiation. Exchange content between client and server using compact encoding, suspend and resume the sessions. The scope of WSP is suited mostly for browsing applications. It offers both connection oriented and connectionless services. Connectionless services is most suitable when applications do not need reliable delivery of data and do not care about confirmations. Then we can look at the features of WSP. WSP offers the following general features needed for content exchange between cooperating clients and servers. There are three major features. First one is session management. In session management, WSP introduces sessions that can be established from a client to a server. We can establish a session from client to server, like data transmission, and may be long-lived. That session may be long-lived. Session can be also released in an orderly manner. It can be in order or unordered. The capabilities of suspending and resuming a session are important to mobile application. The sessions can be suspended and resumed according to the user. The second feature is capability negotiation. Clients and server can agree upon a common level of protocol functionality during the session establishment. During session establishment time, the client can agree upon a common level of protocol. Example parameters to negotiate are maximum client STU size, maximum outstanding requests, protocol options, and server STU size. The next feature of WSP is content encoding. Content encoding is an efficient binary encoding for the content. It transfers through the WSP, that is wireless session protocol. WSP offers content typing and composite objects composite objects. Then we can see what is WSP bar B. WSP bar B stands for Wireless Session Protocol Browsing. That is, while WSP is a general purpose session protocol, WAP has specified the wireless session protocol bar browsing, which comprises protocols and services more suited for browsing type applications. Thus, WSP bar B mostly suited for browsing type applications, which offers the following features adapted to web browsing. It has some features, some major features which is adapted to web browsing. The features are HTTP bar 1.1 functionality. It supports the functions HTTP bar 1.1 offers. It supports the functions which are offered by HTTP bar 1.1, such as extensible request or reply methods, composite objects, and content type negotiation. The next one is exchange of session headers. Client and server can exchange the request reply headers in this WSP bar B. The request or reply headers which is constant over the lifetime of session. Then comes the pull data transfer. Pulling data from a server is the traditional mechanism of web. This is also supported by WSP bar B using the request response mechanism from HTTP bar 1.1. Additionally, WSP bar B supports 3 push mechanisms for data transfer. First one is a confirmed data push within an existing session context. The second one is non-confirmed data push within an existing session context. And the third one is a non-confirmed data push without an existing session context. Then comes asynchronous requests. WSP bar B supports a client that can send multiple requests to a server simultaneously, which makes it asynchronous. This improves the efficiency of the requests and replies. Then we can discuss about WSP bar B over WTP. It's been mistaken by me on the heading. It's WSP bar B over WTP. The WSP bar B uses the three service classes of WTP, where class 0 is used for unconfirmed push, session resume, and session management. Confirmed push uses class 1 method invocation, session resume, and session management class 2. Here we can see the picture of session establishment. The first example of session establishment of WSP bar B using WTS class 2 transaction is shown below. Here we can see that there is S-connect request, then it connects from a client, then it connects PDU, then server sconnect.ind, then there is sconnect.cnf, connection reply PDU. Now I will see what all these are. With sconnect.req or request, these all are known as some primitives. That is sconnect.request primitive. A client can request a new session. It is used to request a new session by client. The parameters are server address SA. SConnect request have the parameters SA, CA, CH and RC. SA stands for server address, CA stands for client address, CH stands for client header, which is optional, and RC stands for requested capabilities. The session layer directly uses the addressing scheme of the layer below. WTP transfers the connect PDU to the server SAP, S bar SAP, where an SConnect IND primitive indicates a new session. SConnect IND indicates a new session. The parameters are same. It has the same parameters as SConnect.request, SA, CA, CH and RC. But now the capabilities are mandatory. Here the capabilities are mandatory. If the server accepts the new sessions, it answers with an SConnect RES. It can be seen here in the server side, SConnect.res. If the server accepts the new session, it answers with SConnect.res parameter. It has the parameters SH and NC. SH stands for server header and NC stands for negotiated capabilities needed for the capability negotiation. WTP now transfers the reply or connection reply PDU back to the client. It is coming from the server side to the client side. The SConnect.cnf. CNF stands for confirmation. SConnect.cnf confirms the session establishment and includes the server header if present and the negotiated capabilities from the server. That is, its parameters are server header and negotiated capabilities. WSP bar B includes several procedures to refuse a session or to abort a session establishment. That is, here it is how the session is suspended or resumed. A very useful feature of WSP is session suspension or resume. A client can suspend the session because of several reasons. Session suspension will automatically abort all data transmission and freeze the current state of the session on the client side and server side, both on client and server side. A client suspends a session with ssuspend.request. Client side we can see that s bar suspend.request. It is used to suspend a session in the client side. WTP transfers the suspended PDU to the server with a class 0 transaction, that is unconfirmed and unreliable. WSP bar B will signal the suspension with ssuspend.ind on the client and server side. The only parameter is the reason R. R is only the parameter of ssuspend.ind. That is, R stands for reason for the suspension. Reason can be a user request or a suspension initiated by the service provider. Also shown that also a client can later resume a suspended session with sresume.request. It has two parameters, SA and CA. SA stands for server address and CA stands for client address. Resuming a session is confirmed operation. It is up to the server's operator how long the state is conserved. Here we can see that SA or CA is the parameters, and it resumes PDU. S dot resume IND. It has also have the same parameters. It replies PDU s.cnf, the same as session establishment works. Now we have seen how to establish a session and how to suspend or resume a session. Next we can see that how to terminate a session. Terminating a session is done by using the sdisconnect.request service primitive. As shown in this figure, we can see that these primitives aborts all current methods or push transactions used to transfer the data. Disconnection is indicated on both sides using sdisconnect IND. For terminating the session, sdisconnect.request is used first in the client side. Then it disconnects PDU, and in the server side it uses sdisconnect.ind. Then it is again transferred to the client side, that same as sdisconnect.ind. All of them has the same parameter R, that is reason. The reason for disconnection can be network error, protocol error, peer request, congestion, etc. Now we have seen that how WSP establish a connection to over WTP for data transmission, and then how it is suspended or resumed, and how it terminates. Now we can see WSP as connectionless session service. It comes WSP could be run on top of the connectionless unreliable WTP services. As an alternative to WTP, WTLS can always be used if security is required. The service primitives are directly mapped onto each other. The following figure shows 3 service primitives available for connectionless session services. We can see the figure here. The sunit method invoke.request is used to request an operation on a server. Sunit method result.request is used to return the result to a client, and sunit push.request is used to push data onto a client. The transfer of PDU's method reply or push is done with the help of standard unreliable datagram transfer service or WTP. Here the sunit method invoke.request has 5 parameters. SA which we know that server address, and CA is the client address, and M is the method, and RU is the URI request, the request URI. Here TID is the transaction identifier. The method invoke.request primitive can determine a transaction identifier to distinguish between different transactions on the user level. TID is communicated transparently from service user to service user. TID is communicated transparently between service users. Here it has the same parameters for unit method invoke.ind. Here the same here s unit method result.request has 6 parameters: CA client address, SA server address, TID transaction identifier, S stands for status, and RH stands for response header, and RB stands for response body. The S unit primitive is the same. Then comes S unit push request. Then comes S unit push request. Here CA is client address, SA is server address, and PID is push identifier, PH is push header, PB is push body. In which is same in S unit push IND. So this is all about WDP, WSP bar B as a connectionless service. This is all about the topics wireless session protocol. Thank you.